class, in terms of force of attraction, we have two types, intramolecular and intermolecular. What separates one from the other, class? Pag sinabi natin intramolecular, it's within the molecule. What are the bonds that exist within the molecule itself? Let's say, for example, the bonds that exist between a water molecule. Okay, so here, say, for example, let's have a water, at least hindi na kasing lala kanina. Okay, so a water molecule. So we have, class, oxygen, hydrogen molecule. Now, class, the bond that exists between hydrogen and oxygen, ito yung intramolecular force that holds the water molecule together. That water molecule. Now, pag sinabi kong intermolecular forces of attraction, what binds one water molecule to another water molecule? Nagets ba? Are we clear? So, kung halimbawa, ito si water molecule, ito pa ang isang water molecule, hydrogen, oxygen. Okay? Palitan natin ng kulay para masaya ang buhay. Red. Okay? So sabi natin, di ba, si oxygen mag-bind dito kay hydrogen, tapos si hydrogen mag-bind dito kay oxygen. So this is what we call, class, at intermolecular force. Intermolecular, between two molecules. Pero, class, yung blue dito, okay, this one, this is an intramolecular force. So are we good? Very good. Okay, magkaiba kasi yung, class, ang force of attraction within the molecule itself and from molecule to another molecule. Are we good? Okay.
Yes po.
So yun. All right. So for intramolecular force, class, dalawa na naman ang common dito. We have what we call an ionic bond and a covalent bond. Okay? So, class, an intramolecular force is a force that exists within the molecule itself. So, it's a force that holds the atom's ions in a compound. Okay? So, if a compound, class, exists, di ba sabi natin, compound consists of various atoms, of various elements. Okay? What keeps them together is the intramolecular force. Now, the intramolecular force, class, that we have comes in two types, either ionic or covalent. Okay? Dito pa lang, class, sabihin ko sa inyo, pag ionic bond, class, this one has a formal charge. Formal charge, meaning one is positive, one is definitely negative. One is definitely positive, one is definitely negative. Sa covalent bonds kasi, class, dito pumapasok ang sharing of electrons. Okay? If the elements, the atoms within the molecule are sharing, nag-share sila ng electrons sila, then the bond that exists between the two, class, is called a covalent bond. Are we clear? Are we good? Sharing. Pag ionic bond kasi, class, ito yung nagdo-donate ako ng electron. Okay? Nagdo-donate ako ng electron. Hindi lang share. Dinodonate ko kasi excess ako. Okay? May excess amount of electrons ako. Right? So, class, for ionic bond, we call this an electrovalent bond. Okay, kasi ang charge mismo nila ang nagkikreate ng bonds dito. Okay? So the electrostatic force of attraction between ions of opposite charge. We always say, class, that a negative ion is highly attracted to a positive ion. Okay? So electrostatically speaking, class, they are going to link with each other. Okay? Based on their charges. So the ions are formed from atoms as a result of electron transfer. Okay? Kaya nga sabi ko sa iyo, class, nag-donate siya ng electron. Hindi lang siya nakipag-share. Pag nagkaroon kasi, class, ng electron transfer, the bond that will exist between those two molecules will definitely be ionic. Ano ba? Naglag ako dun, ha? Okay? So what exists, class, will be an ionic bond. It's a very strong bond. Sa lahat, class, ng bonds na meron tayo, ionic bond is the strongest. Okay? Ionic bond will always be the strongest. So formed as a result of a large difference in electronegativity of your ions. So formed between metals and non-metals. Katulad sinabi kay Miss Pejoto. Okay, so it's usually an interaction between a metal and a non-metal. So like sodium, chlorine, potassium, chlorine. Okay, yung mga salts natin, right? Okay, it's the interaction between a metal and non-metal. Okay, and we call it an electrovalent bond. Kaya siya kasi electrovalent again kasi may difference talaga sa charge nila. Okay, one is positive, one is negative. The other one kasi is called covalent kasi nagkakaroon tayo ng sharing. Okay? Di ba parang cooperate? Di ba? Parang cooperate. Collaborate. Okay? Meaning may sharing tayo. Okay? Kaya covalent. Okay? Nag-sharing naman sila ng electrons nila. Are we good so far? Okay. So class, between an ionic bond, as I mentioned a while ago, class, there is a transfer of electrons. Now class, once the electron is transferred kasi, okay, one molecule will exist in its positive state, definitely, while the other molecule will exist more on its negative state. Kasi tingnan nyo, si sodium dito kayo na class, may excess electron. Okay? So kumbaga, yung excess electron na yon, kasi di ba sabi natin, electrons will always exist in pairs. Pag in pairs na kasi yung electrons natin, yung, nakikita niyo ba to? Yung paired, mga yan. Okay? So class, they always exist in pairs. Pag in pair kasi siya class, ang tendency is stable ang electrons natin. Okay? Now class, dahil may isang excess electron si sodium kanina, okay? Si fluorine, kulang ng isang electron. Kasi tingnan mo, lahat ito naka-pair except for one. Okay? So dinonate ngayon ni sodium yung kanyang electron. Now, dahil nag-donate si sodium ng electron, donate, ano nangyari ngayon sa charge ni sodium? Nag-donate siya eh.
Naging positive po.
Very good. Dahil nag-donate siya, nawalan siya ng electron, and electron is negatively charged, so naging more positive si sodium. Eh si fluorine, kaya nakulang ng electron, nabigyan ng electron. Okay, so tendency class, dahil nadagdagan siya ng electron, which is negatively charged, okay, so therefore si fluorine mas naging negative. So ngayon, si sodium na mas positive, si fluorine na naging mas negative, apple pen, pineapple pen. Oh! Okay? Ay, gets yun na yun. Okay, pen, pineapple, apple pen. So yun, nagkaroon ng force of attraction. Okay, si sodium na mas positive at saka si fluorine na mas negative. Okay? Okay. So yun. Ganyan ang ionic bond class. Basta tandaan nyo lang, sa ionic bond, nagkakaroon ng transfer of electrons. Yun yun. Okay, another thing that you have to remember here is, nagkaroon ng transfer of electron. It's usually between a metal and a non-metal. Alright? Okay. So yun, at least that's clear. Kasi kasi mga tatanong ko lang naman dito sa quiz natin eh, what bond exists between these two molecules? And again, tapos follow-up question, what could be an expected property? And so on and so forth. So what is electronegativity? Sabi nga, the ability of an atom to attract or pull electrons to itself. So the more electronegative a molecule is, okay, the higher ang chances na manghatak siya lalo ng electrons. Okay? Let's tingnan nyo class, carbon and oxygen are both electronegative, pero which one is more electronegative? It's oxygen. Okay, it's oxygen. Kaya pag pinaghalo mo si carbon at si oxygen, si carbon ang kawawa. Siya nanakawan ng electron. Hindi naman nakaw. Siya nakikipag-share ng electrons. Pero between carbon and hydrogen, sino mas electronegative?
Carbon po.
Definitely si carbon. So siya yung nangahatak ng electrons kay hydrogen. So maliwanag tayo doon? Yun. Okay? So the more, basta usually kasi ang babasyan mo lang naman dyan, titignan mo lang, sino mas electronegative? Labas mo yung periodic table. Okay? So what are the properties class of ionic bonds? Of drugs that exist in their ionic state. Normally class, drugs that have ionic bonds, or molecules that have ionic bonds, exist in their crystalline solid states. Kasi napakalakas ng bond nila, di ba? Excuse me. Like sodium chloride. Okay? Ano bang available, ano ba itsura ng sodium chloride natin? Di ba? In its pure form, it's solid. Okay? Kasi ang bonds that exist between the molecules is, right? Very tight. So, if a molecule class has a high ionic bond, ang tendency class, yung kanyang melting point is very high. Meaning, hindi mo yan agad-agad matutunaw. Ilagay mo class sa frying pan ang asin. Put it on max heat. Sa tingin nyo, matutunaw yung asin agad? Okay? Matutunaw ba yung asin agad? Na-try nyo na ba? Na-try nyo na ba magprito? Try nyo yung prito asin class. Kahit anong prito nyo dyan, hindi yan matutunaw ng basta-basta. Okay? Sa sinangag. Pero yung sinangag kasi nakakuha ng moisture yun from the rice eh. Okay? Nakakuha ng moisture from the rice kaya medyo natutunaw siya. Pero usually, makikita mo pa naman yung asin doon, solid eh. Pero kasi class, kaya mas solid yung asin doon kasi usually may mantika rin tayong involved. Okay? Different topic na altogether. Right? Pero yes, pwede siya maging charred. Pero it's still solid. So it's difficult class to melt a substance that contains ionic bonds. So are we clear? At the same time, class, its boiling point will tend to is also high. Kaya tingnan nyo, class, kung gusto mo, kung ayaw mong kumulo agad yung, yung tubig mo, anong gagawin mo? Dagdagan mo lang ng asin. Kaya nga, di ba pag nagluluto tayo, pakuluin mo muna ang tubig mo bago mo lagyan ng asin. Tama? Sino ito mga nagluluto? Okay, wala? Nagkakain lang po ako, sir. Dati ganyan din ako, pero ayun, yan talaga buhay. Adulting, kailangan matutong magluto. Para mo yun lang. Okay. So, class, diba, before mo, or before pag nagluto ka, class, usually, okay, lalo na pagsabaw, last nilalagay ang asin. Last ka nagtitimpla. Kasi, class, pag nilagay mo agad ang asin, matatagalan bago kumulo yung pinapakuluan mo. Okay? Because nga, adding salt, class, would increase the boiling point of your substance, of your water. Mas tataas yung boiling point niya. Instead na dapat kumulo siya at 100 degrees Celsius, at a higher temperature pa siya. Okay? Okay. So anyway, another property class of ionic bonds, if a molecule has ionic bond, they tend to conduct electricity. Okay? Kaya nga, di ba, between pure water and salt water conducts electricity. Right? In molten and aqueous states. So they are hard and brittle, but soluble in polar solvents. Okay? If a drug contains ionic bonds, then most likely, class, ang kanyang polarity or ang kanyang solubility will be towards polar solvents. Okay? More on polar solvents. Kasi a polar solvent, class, would mean it has either positive or a negative charge. That's the reason why, class, if salt, like sodium chloride, can easily dissolve in water. Kasi, class, sodium chloride, iba-iba yung kulay nito eh. Si sodium, kunwari na positive, effort match to Okay, si chlorine na negatively charged. Okay. Ibang color naman. Tapos kunwari ito si oxygen na negatively charged. Tapos si which contains hydrogen molecules which are positively charged. Okay? So it's a dipole. So, ang tendency, class, is yung sodium which is positively charged, mas mataas ngayon ang affinity niya towards oxygen. So, maghihiwalay siya. Kasi chlorine naman, which is mostly negative, magbabind naman siya kay hydrogen. So, class, nagkakaroon siya ng dissociation. So, mangyayari dito is, hihiwalay ito. So, si sodium, nakaband na kay oxygen, while si chlorine, nakaband na kay hydrogen. So, nagkaroon tayo ng tinatawag na dissociation. Right? Nag-dissociate si sodium at saka si chlorine into its positive charge and negative charge. Nagets ba? Nagkaroon ng complete dissociation. Naghiwalay talaga yung dalawang molecule. So, maliwanag ba tayo doon? Are we good so far? Okay. So, yun siya. Kaya mas soluble usually, class, ang mga molecules that contains ionic bonds sa polar solvents, like water. Okay, it's polar, meaning it has a charge. Are we clear? So, pag sinabi natin, class, polar ang isang substance, ibig sabihin, may charge siya. Pag sinabi kong non-polar,
Wala pong charge.
very good. A non-polar substance, class, has no charge, like oil. Okay? Oil, mantika. Oil. Yun, oil. Ngayon ang pinamagandang example doon. Okay, what about covalent bonds, class? So sabi natin, pag ionic, there's a formal charge. Okay? The bond between a positively charged and a negatively charged substance. Covalent bond, on the other hand, class, exists when there's only a small difference in electronegativity. Okay? Between the two molecules. Like carbon and oxygen. Konti lang naman ang difference in terms of electronegativity. So, usually this is formed by overlapping of atomic orbitals. Wherein, class, electrons are, the keyword here, class, is shared. Okay, that's the keyword here. The electrons are shared. So, di ba sabi natin, tawag dito? Basta yun na yun. Okay? Tatandaan nyo kasi nagkakaroon ng sharing ng molecule, ng electrons. I think familiar na rin naman sa ito, di ba? Yung mga clouds, yung electron sharing. Okay, I think this was familiar na sa inyo. So, inisip ko, di-discuss ko pa ba? Tatagal ako lalo. Kaya hanggang 12:30 lang pala tayo. Okay, so wag na yon. Basta nagkakaroon ng sharing of electrons. Okay, between nuclei of the two atoms which holds the molecules together. Now, class, normally, two types of bond can exist, a sigma bond and a pi bond. Okay, of course, class, a sigma bond is a very strong bond. Okay, this one is strong. A pi bond is weak. Right? Pero if there's a sigma bond plus a pi bond, then obviously, mas malakas ang sigma plus pi kumpara sa sigma bond lang. Tama? Nagets ba, class? Okay. Diba ito, actually yung bonds na to, mas common to sa naming nyo, yung dienes, ones, alkanes, alkenes, alkynes. Naalala nyo sa organic med yun? Diba alkanes, pag single bond, may sigma bond lang si carbon. Usually covalent bond kasi yung nag-exist kay carbon to carbon eh. Okay? So, nag-sharing kasi sila ng electrons. So, that's a covalent bond. Now, I know it's a covalent bond. So, kung sigma bond lang yon, it's an alkane. Diba? Lahat ng everything ends in A and E. Tapos, pag may pi bond na nag-exist, one pi bond, alkene. Okay? Tapos, pag tatlo na yung bonds na nag-exist, may isang sigma bond, tapos sa labas nun will be the pi bonds, that's an alkyne. Okay? The more bonds that exist, class, obviously, mas stronger yung bond na yon. So, are we good? Okay. Pero class, between the two, sigma and pi bond, sino ang unang nababali? Sino ang unang nagbe-break? Si sigma or si pi bond? Okay, very good, Mr. Sean. It's the pi bonds. Okay, pi bonds ang unang magbe-break dyan. So, halimbawa, di ba, an interaction between carbon to carbon. We know, class, that carbon can exist in this state. Di ba, si carbon, kaya niyang i-separate yung mga electrons niya. 4 kasi yung electrons niya, di ba? Normally, ang sabi natin, dahil 4 yan, edi obviously, sir, magpe-pair na yung dalawa. Stable agad si carbon. No. Di ba sabi natin, class, carbon has a unique property wherein yung kanyang electrons, hindi sila nagpe-pair, hindi sila nagpe-pair up, nagse-separate sila into 4 distinct groups. Correct? Okay. So, class, if a carbon binds to another carbon molecule, nag-share sila, this is a covalent bond. Okay? At it's a covalent bond, right? Pero dahil ang sharing nito is between carbon to carbon, like this one, okay, isa lang ang binding nila. So, obviously, this is a sigma bond. Correct? That's a sigma bond. Now, class, if another carbon molecule, carbon to carbon, pero this time, 1, 2, 3, 4, 2, 3, 4. Ang bonding nila is between two electrons. Nag-sharing yung dalawang electrons nila. Okay? Then one here is sigma. Nakalimutan ko na kung itsura ng sigma. Di ba, ganito nga ba sigma? Darn it. Ganito, no? Tama nga ba? Sorry, nakalimutan ko na, ha? Okay, pero sabihin natin sigma bond, yung isa dito, tapos yung isa would be obviously be a pi bond. Okay, so now, kung kailangan i-break yung isang bond dito, una mag-break dyan yung pi bond. Si sigma bond will stay as is. Are we clear? Kasi between sigma and pi, mas strong si sigma bond. Okay, like halimbawa, makikipag-bond siya ulit sa iba pang molecules, like hydrogen, say for example. So dahil makipag-bind siya, okay, kailangan mas electronegative pala, oxygen na lang. Okay? Nagigets pa ba ako? Baka medyo nagiging technical na ako. Palitan ko na yung yung kulay ng ink ko. Okay, so say for example, class, ang scenario natin is carbon to carbon. So dalawang bonds ang nag-exist. Ito yon dahil dito. Ngayon, class, pumasok, halimbawa, si oxygen. Oxygen molecule. Right? So, sino mas electronegative? Si carbon o si oxygen?
Oxygen po.
Si oxygen ang mas electronegative. So, obviously, class, sabi ni carbon, hindi ako makikipag-share sa, kunwari may hydrogen na dito. Okay? May hydrogen na dyan. 1, 2, 3, 4. 1, 2, 3, 4. Kasi kailangan 4 lagi ang molecule nakatouch kay carbon. Ngayon darating si oxygen. Sabi niya, ayoko makipagpalit kay hydrogen. Papasok ako dito. Okay? Dito papasok si oxygen kasi free yung electron na to. Alright? Free yung electron na yan eh. Dito ngayon papasok si oxygen. So ngayon class, ito si sigma, ito si pi bond. Okay? Dahil class, bond to each other lang naman ito, dahil mas electronegative si oxygen, obviously, ano mangyayari sa bond na to? This one will break, definitely. Kasi mas electronegative si oxygen. So pag nag-break yung bond na yan, dito yan kakabit. Okay? Dito ngayon sila makipag-sharing. Okay? Hindi mabe-break ni oxygen yung sigma bond kasi mas matigas yan eh. Matigas yung bond na yan. So, between the two, mas pipili niya syempre si pi bond. Okay, yung pag-sharing niya ng electrons dyan. So, dito kayong kakabit si oxygen. So, maliwanag ba tayo? Tandaan nyo, class, ha? When actually, sa organic medicinals nyo na to. Okay? Pero kapag nakakita ka sa pi bond existing in a structure, automatic class yan ang laging target ng much electronegative molecule. A molecule that's more electronegative will always target the pi bond. Why? Kasi pi bond is a lot weaker. Weak siya. So, syempre, kung ako may maghanap ng kaaway, pipiliin ko yung mas maliit sa akin, syempre. Yun ang bubugbugin ko. Mas maliit yan eh. Kaya ko yan. Syempre, di ko kakalaban yung mas malaki sa akin. Di ba? Okay? Nagets ba kasi yung analogy natin? So, something like that. So, pipiliin niya class yung pinaka-weak na bond sa kaya niyang i-break. Hindi sisingit si oxygen dito sa kay hydrogen. Kasi between carbon and hydrogen, it's still a covalent bond. It's still a sigma bond. Hindi sisingit dyan hanggat maaari. Ulitin ko ang term ha, hanggat maaari. Kung mayroon naman kasing existing na pi bond, uunahin niya i-break yung pi bond. Okay? Are we good? Okay. Pero class, kung walang existing pi bonds dyan, di syempre, pipiliin niya yung the least electronegative, dun siya sisingit. Okay, which is oftentimes the hydrogen molecule. Now, this one is more of organic med na. Okay? Pero at least familiar tayo dito. So again, class, pag covalent bond, there is sharing. Okay, let's say for example, a non-metal and another non-metal. Kasi pag metal, non-metal, obviously, ionic ang mag-exist dyan. So metal, non-metal, non-metal. Okay? So both have a, may lone pair sila ng electrons. So ang tendency is, may kipag-sharing na lang sila. Okay? Once nagkaroon ng sharing of their available valence electron, so that's already creating a covalent bond. Now, a covalent bond class can either exist as a single bond, double bond, or triple bond. Pero there will always be only one sigma bond lang, tapos 2 pi bonds ang pwede. Okay, so halimbawa, the covalent bond class that exists between the hydrogen and oxygen molecule, okay, is a sigma bond. Okay, so sharing sila dito eh. Ayan, no? Sharing sila. Okay? So that's a sigma bond. Now, class, si carbon dioxide naman, on the other hand, okay, dalawang electrons niya ang shinare. Right? So therefore, one is a sigma bond, the other one is a pi bond. Okay? And between a nitrogen molecule and 3, di ba 3 yung kanyang valence? Okay, nitrogen has 3 valence. So class, we know that nitrogen exists in its diatomic state. Pag sabi natin diatomic state, ano ibig sabihin nito? In its free state, nitrogen will always exist as N2. In its free state. Walang N lang. Okay? In its free state class, you will never find nitrogen as N lang. Okay, like oxygen, di ba? Oxygen, in nature, will always be available as O2. It's always existing in its diatomic states. Are we clear? Diatomic. Okay? Ano bang alam nyo, class, na molecule nag-exist in its diatomic state? Another electron. Yes, Miss Pihoto?
Calcium po ba? Di ba?
No, sorry.
Positive
Calcium
pala.
class, no, calcium does not exist in its diatomic state. It can exist as calcium lang, as Ca. H2, hydrogen. It always exists in its diatomic state. Okay, tandaan nito class, chlorine is another molecule that always exists in its diatomic state, chlorine. Okay, halogens and noble gases. Yes, iodine is a halogen. Remember, iodine is always exists in its I2. Fluorine din, Fl2. Okay? Kasi class, tandaan nyo to ha, all halogens and noble gases always exist in their diatomic states. Yes, nitrogen, definitely. Ito yun. Asan na yun ako? Okay, so si nitrogen natin. Yes. Basta class in halogens, tandaan nyo na, I think familiar na naman kayo kung alin yung mga halogens sa ating group 7A, if I'm not mistaken, sa ating periodic table. And then the noble gases. Okay? So they will always exist in their diatomic states. And when they exist in their diatomic states class, the bond that exists between them will always be a covalent bond. Are we clear? Kasi nagkakaroon ng sharing. Walang agawan, sharing lang. So we're good so far? Okay, biruin nyo, nandito parang tayo. Tapusin ko lang to, then we have a break. Okay, nasa intramolecular forces pa lang tayo. Okay? Okay, so what's the property now of a molecule that has a covalent bond? Oftentimes, class, between ionic kasi and covalent, sino mas matigas? Sino mas strong? Ionic and covalent. Mas strong
Ionic po.
si ionic. Very good. Mas strong si ionic kasi talagang, ganun yun. Negative, positive eh. So may formal charges siya. Between covalent bonds, class, this one is usually for molecules with dipolar molecules. Meaning may partial positive, partial negative. So nagkakaroon tayo ng sharing. So oftentimes, class, if a molecule has an intramolecular force as a covalent bond, they can often exist in either liquid or gaseous states at room temperature. Okay, they exist either liquid or gaseous states. Okay, depende na kung gaano kalakas yung attractive forces that exist. Kung medyo malakas, obviously liquid. Kung hindi ganun kalakas, obviously they will exist in their gaseous states. Okay? So, they relatively have low boiling points. Ibig sabihin, mabilis lang sila magkumulo. Okay? Kaya nga yung mantika, di ba, mabilis lang kumulo. Alright? And they do not conduct electricity. They are usually insoluble in polar solvents kasi hindi sila naghihiwalay agad-agad. They don't separate. They don't dissociate in polar solvents. They are usually soluble in non-polar solvents. So remember a while ago, class, I mentioned, di ba, bakit ganito yung shape ni water molecule? Okay? Ayan si hydrogen, ayan si oxygen. Okay, tapos kanina si carbon dioxide, ang shape niya is more like this. Okay, ba't siya ganyan? Ba't siya straight? Okay. Now, class, the reason why, class, nagbe-bend, may angle yung may angle si hydrogen molecule. Okay? It's simply because, class, malakas ang attractive forces or ang electronegative force ni oxygen. Okay? So we know, class, that oxygen is greatly more electronegative than hydrogen. Okay? So the tendency, class, is as it pulls hydrogen towards itself, okay, nagkakaroon siya ng tinatawag natin na angle. Okay, nagkakaroon siya ng angulo. Unlike, class, between oxygen and carbon dioxide sa CO2, carbon dioxide. Okay, tandaan nyo, class, dalawang highly electronegative molecule ito. Okay, although, syempre, in terms of electronegativity, hindi naman sila ganun ka-different. Okay, they're not that different. Right? Pero syempre, mas electronegative pa rin si oxygen. So, tendency, class, is ang hatakan, pag ganito. Pag ganun. So, pag ganyan ang hatakan, ano nangyari kay carbon? Gigit na siya. So, maliwanag ba? So, mas gigit na siya. Sa case kasi, class, ng water, ang hatak pa ganun. Pag ganun yung hatak niya. So, tendency, si hydrogen, gaganon. So, nagets ba, class? Nagets ba?
Yes, po, sir.
Kaya usually ganito ang itsura niya. Kasi ang hatak, class, ni oxygen, pataas na ganun. Okay? Nahatak niya pataas yung dalawang molecules ng hydrogen. Yung electrons ng hydrogen. So, natakatangay ngayon si hydrogen, kaya nagkakaroon siya ng angle. Eh, dito naman sa carbon dioxide, or any molecule, class, wherein napapagitnaan yung yung least electronegative sa gitna, ang tendency, class, ang hatakan pa ganun. Kaya the proper way of writing, class, kung gusto mo talaga ng pati yung orientation ng inyong molecule ay i-explain natin, dapat pag ganito yan, straight line siya. Right? So, are we good?
Yes,
Okay.
po.
So, yun lang naman yan. Now, class, let's talk about the intermolecular forces of attraction. So, sabi nga natin, these are the forces between molecules or ions and influence their properties. So, class, kanina, we were talking about ionic bonds and covalent bonds. Now, again, these are the bonds that exist within the molecule itself. All right? Now, this time, class, molecule to molecule na. Ang pag-uusapan natin. So, the intermolecular force, class, can be usually classified into two. Okay, we can have the van der Waals forces, and then we have the hydrogen bond. Actually, class, hydrogen bond is just another type of van der Waals forces. Pero sineparate natin siya kasi very significant ang role, class, ni hydrogen bond, especially for pharmaceuticals in terms of their biologic actions, their properties, and so on and so forth. Okay? Okay, so molecular polarity, class, gives rise to the forces of attraction between molecules. So, kumbaga, class, a molecule tends to be attracted to another molecule because of their polarities. Okay? If the positive side of the molecule is attracted towards the negative side of another molecule, and vice versa. So, class, these forces are electrical, okay, and usually results from mutual attraction or mutual repulsion. Again, depends on. Now, non-ionic interactions between molecules, class, usually plays a role here. Okay, and then weak forces, these are usually weak forces that involve the dispersion of charge across a molecule called a dipole. So responsible for the states of matter. Okay, so kumbaga class, our drugs, our molecules, or our substances can exist in various states of matter, liquid, solid, or gas, because of the van der Waals forces. Okay, or the interaction between these molecules. So, van der Waals force class are usually weak forces than more weak than covalent. Okay, between covalent and ionic, definitely. So molecular interactions involve insolubility, complexation, and numerous other physical bonding phenomenon. So class, when we talk about complexation reactions, yung pag-bind ng drug molecule to its receptor, usually class, ang involved dito would be the van der Waals forces. Usually. I'm saying all the time, pero usually it's the van der Waals forces. Kaya nga class, ang binding between a drug molecule to its receptor is usually reversible. Okay? Unless class, the bond that exists between the receptor and the molecule is a covalent type of bond, which is, of course, leads to an irreversible type of bond. So it exists between all atoms and molecules, critically dependent on the separation distance of the atoms or molecules from each other. So for the van der Waals forces class, we have the following. Okay, so you have the ion dipole, the dipole-dipole, or what we call the Keesom forces. Feeling ko familiar na sa inyo to, right? Narinig nyo na? Yung mga terms na to? Okay, dipole-induced dipole, induced dipole-induced dipole interactions, or ion-induced dipole. Okay? Okay, so first things first. Okay, let's try to separate muna ulit ang characteristics ng mga to. Pag ion, ano ibig sabihin nito? Sabi natin, these are molecules that
have charge po.
Very good. Definitely, well, dipoles also have charge, but we say class they have a formal charge. Okay? So, mas ano yung term na yan. Alright, so an ion has a formal charge. Okay? Ibig sabihin, garantisado, pag positive, pag sabi ko positive, positive talaga yung charge niyan. Pag sabi ko negative, negative talaga yung charge niyan. That's an ion. Okay? A dipole, on the other hand, sabi na dito, okay, may charge din naman siya, pero partial. Okay? So it has what we call a partial charge. Ibig sabihin, class, it's partially positive. At the same time, it can also be partially negative. So that's a dipole. That's a dipole. It's a molecule with two polarities. Alright? An ion is a molecule that has a charge. Has a formal charge. Yun na lang, mas magandang term dyan. Kasi partial charge, charge pa rin naman yun eh. Okay, so it's a partial charge, the other one has a formal charge. Now, when we say class induced dipole, okay, mamaya I'll discuss this more later. Pero an induced dipole class is a substance na napilitan lang mag-separate ng charge. Okay, kumbaga class, sa mga molecules natin, ito yung mga molecules na marupok. Sinabi niyang hindi siya bibili sa Shopee. Biglang nag-flash sale yung kanyang gusto. Right? Marupok siya, napabili siya. So parang nag-adjust siya para kay Shopee. Alright? An induced dipole class, kaya nga term is induced. It's not really a dipole molecule, pero parang napilitan siya mag-separate ng charge niya. So maliwanag tayo? Okay, I'll talk more about this later pag nandiyan na ako sa topic na yan. Pero what I want you to know, class, is that the difference lang naman kasi between a dipole and an induced dipole, garantisadong hiwalay talaga yung charge niya. May positive, may negative. Okay? Si induced dipole, napilitan lang mag-separate. Napilitan siya for whatever reason. I'll explain this one more later. Kaya siya term na induced. Okay? Napilitan. Alright? Now, class, so yun, meron tayong induced dipole. We also have the induced dipole, meaning yung induced dipole may pag-bind sa isa pang induced dipole. Right? Kumbaga nagsama yung dalawang napilitan lang. Kumbaga sa kasalan, isang pangit, isa pang pangit, napilitan na lang daw yun, no choice. Okay, biro lang yun ha. I don't know if you know that joke. Sabi nila, pag pareho maganda yung pag pogi, ganda, kakasal, match made in heaven. Pag maganda yung babae, pangit yung lalaki, galing diskarte ng lalaki. Pag pareho daw pangit, babae, parehong pangit lalaki, ano na yun? No choice. Okay? Pero anyway, didelete ko na lang yun sa ating pag in-edit ko na to. Pero yun guys, induced dipole is simply the bond nga between napilitan. Okay, napilitan lang sila mag-separate ng charge nila. Okay? So tapos next is ion-induced dipole. An ion is binding to a molecule that is an induced dipole. Okay? Okay, so dipole-dipole muna tayo. Sabi natin guys, pag dipole, again, a dipole molecule has both positive and negative ends. meaning part of it is positive, some parts of it is negative. So usually results from electrical interaction between an ion and a partial charge or on a polar molecule. So the dipolar molecule class orients themselves with a positive end of the dipole near the anion and a negative end near the cation. Okay? So a good example again, class, would be water. So sabi ko sa inyo kanina, di ba? Kasi ang hatak ni oxygen class pataas. Kasi nahatak niya si hydrogen, yung electron si hydrogen. So tayo class, si hydrogen nagkakaroon siya ng angle between 52.25 degree angle. So gumaganon siya yung angulo niya. Okay? Class, malaki ang role ng angling na yan kapag nag-start na mag-phase change or mag-interface change ang water. Ano ba, pag siya ay naging solid, naging gas, okay, yung angle na yan between the hydrogen and the oxygen nagbabago. Okay? So anyway, so that's called a net dipole. Here's the net dipole for water. Okay, and then a net dipole for carbon dioxide, na-explain ko kanina, when yung hatakan class is parang tug of war. Kaya ang nangyayari is naging straight line yung structure niya. Naging straight yung structure niya. Okay, kasi nga mas electronegative si oxygen kumpara kay carbon. So ang tendency is yung electron ni carbon, sinishare niya kay oxygen. So nakukulangan ng konting electron si carbon, kaya nagiging mas positive siya. So I think I've explained this a while ago, right? So yun ang ibig sabihin class namin ng dipole molecule. Dipole, again, dipolarity. Two polarities, positive and negative. Okay. An ion dipole force naman class is an attractive force that results from the electrostatic attraction between an ion and a neutral molecule that has a dipole. Okay? Most commonly found in solutions, especially for solutions of ionic compounds, like salt water, say for example. Combination of salt and water. So it's very important class, yung interaction na to class, ion dipole forces, it's very important class for diuretics. Like say for example, furosemide. Why? Okay, furosemide kasi class tends to so these like diuretics increase the volume of urine and remove the excess electrolytes and fluids. So they attract more sodium molecules. Okay, because the furosemide is a dipole molecule that is polar. Okay, we'll talk more about that. You'll talk more about that sa organic medicinals naman. Okay, yung forces of attraction between the structure of furosemide and how it affects its potency. How it is able to attract sodium molecules. Pwedeng organic med or sa pharmacology, either way. Pero usually ni-discuss sa organic med class, yung structure-activity relationship. You've heard, meron ba kayong organic med? Wala pa. Okay. Masaya ka sa organic med. Madugo pero masaya. Masaya siyang aralin. Okay. So as I told you a while ago, class, in ion dipole forces, so sabi natin, if this is water, say for example, so this is oxygen, this is hydrogen. So tignan pa isa dyan. Ito, dalawang molecule dapat ng hydrogen yan. So class, an ion, okay, an ion class would either be a positively charged ion or a negatively charged ion. If an ion is positively charged, okay, it's called a cation. If it's negatively charged, it's called an anion. So in sodium chloride, okay, sodium chloride, sino ang cation? Obviously, see?
Sodium.
Definitely, very good. That's sodium, and then the anion would be chlorine. Okay? Kaya nga class, pag nilagay mo si sodium chlorine sa water, they undergo what we call dissociation. Dissociation. Pag sinabi natin class, dissociation, okay, naghiwalay si positive at saka si negative. Okay? Naghiwalay si positive at saka si negative. Kumbaga, si water molecule dito yung third party, pinaghiwalay yung dalawang mag-asawa. Okay? So talagang complete dissociation. Alright? Okay. Class, I need you guys to know this term now because once I start talking about the Henderson-Hasselbalch equation, pH, pKa, involved kasi ang dissociation dito. Right? So I need you guys to be familiar with the term dissociation. Again, naghiwalay lang si positive at si negative dito. Okay? So ang nangyari dito, class, obviously, when there's an ion dipole force, okay, ang nangyari, class, dahil nag-dissociate na yung ions into its separate charges, positive and negative, okay, si cation will obviously go to the negative charge of the dipole, which is the oxygen. So dito siya kakabit. Tapos si anion, which is negatively charged, kakabit naman siya sa positive charge ni hydrogen. Dito siya may kabit. Okay, kumbaga. Are we clear? Are we good? Okay, kaya siya tawag na ion dipole forces. Okay, the force that exists between an ion and a dipole. Okay, kung saan sa dipole, aalamin niyo yun. Right, kung aling molecule sa dipole. Okay, next one. So, So ion dipole force class accounts for the solubility of ionic crystalline substances in water. Okay, and the cation attracts the negative oxygen atom of the water, and then the anion, which is like the chlorine, attracts naman the hydrogen atoms of the dipolar water molecule. Okay, so kaya between the two, so si sodium kakabit kay oxygen, si chlorine kakabit kay hydrogen. Yan siya nagkakreate ng bonds. So hence, I have now a sodium chlorine water. A water that is diluted in sodium and salt water na lang. Okay? Okay. So can I still separate sodium chloride from water? Possible ba na i-separate ko pa to? Can I separate them? Tingin nyo. Okay. Kasi ang tatanungin ko lang naman dyan ulit sa inyo is, what type of bond ba exists between sodium chloride and water? We call it the ion dipole force. Or general, ang umbrella, ang pinaka term would be van der Waals forces. Okay? And remember guys, van der Waals forces are what type of bonds? Strong or weak?
Weak po.
Weak bonds. Very good. Dahil weak bonds sila, class, kaya ko pa yung silang paghiwalay. Kumbaga, class, pag van der Waals force na nag-exist sa inyo ng inyong jowa, mabilis pa yung ma-break. Okay? Kumbaga, may dumating ng mas more electronegative na atom, na tao, mas electronegative, mas maganda, mas mayaman. Okay, so tendency is, mabilis ma-break yung bond na yun. Kung van der Waals forces na nag-exist. Kaya kailangan, between you and your jowa, dapat meron kayong ionic bond. Kung hindi ionic bond, kahit covalent man lang, may sharing. Okay? May sharing of electrons kayo para medyo strong ang bond ninyo. Kumbaga, kasi pag ionic bond yan, usually kasal na yan, may papel na yun. Alright? So nag-gets ba kasi mga relationship ng mga ganyan. Okay, I usually try to relate it to things that can easily be understood by most students. Right? So kaya pa ito klase break. Anong gagawin ko? Papakuluan ko lang yung tubig. Okay? By adding water, by adding heat class, heat can actually break these bonds. Now, dahil malapit si hydrogen molecule kay oxygen, tendency is malakas-lakas ang bond niya. So hindi sila naghiwalay agad-agad. Although the bonds between water to water, pwede maghiwalay kaya nag-exist in its gaseous state. Okay? So pwede mag-break to. So pag nag-break ang bonds na to, saan didikit niya yung sodium sa chlorine? Magbabalik din sila. Okay, hihiwa-hiwalay pa pala sila. Yun pala, at the end of the day, sila pa rin dalawa palang magkakasama. So are we clear? So once I apply heat here, mag-break yung ion dipole force na to. So si water molecule, hihiwalay. Kasi malakas-lakas ang covalent bond na nag-exist dito eh. Covalent yan. Okay, so stick pa dyan si hydrogen kay oxygen. So maghihiwalay sila. Ngayon, dahil naiwan sa ere si sodium sa si chlorine, sabi nila, hala, pareho tayo naiwan sa ere. So, sige, tayong dalawa na lang ulit magsama. Sige, tayo na lang ulit dalawa. Okay? Nagets ba, class? So, sila ngayon ulit magsasama. Kasi umalis na si water. So, maliwanag? Very good. And I usually just did that by application of heat. Okay? Remember, class, ang representation natin lagi sa heat is a triangle. Okay? So, I think familiar na kayo. Familiar na kayo dito. Alright? So yun, ion dipole. Next one is the dipole-dipole, or what we call the Keesom forces. It's a Keesom forces class. This is the interaction. It's also known as the orientation force. Okay, it's more on orientation of the molecule. The interaction between a permanent dipole with polar molecules. So an interaction between a dipole and another dipole. Okay, so no, it's named after Wilhelm Hendrik Keesom, whatever. Okay, salamat sa contribution of Mr. Keesom. Okay, energy of attraction is usually 1 to 7 kilocalories per mole. Okay, ito yung energy that requires that keeps them together. Okay, examples of substances class with permanent dipoles includes water, hydrochloric acid, alcohol, acetone, or phenol. Okay, so syempre, bibigay ko example ito is water, pinakamadali. Yan. Okay, so ito tayo kay water. So si water class, sabi nga natin, actually I've explained this a while ago. Yan, si oxygen, hydrogen, hydrogen. Di ba class, water molecule can bind to another water molecule, correct? Pwede sila magdikit-dikit. Okay? Kaya nga they can exist in so many states of matter. Okay? Because of this orientation of theirs, yung ganung orientation nila, yung ganun. Okay? At the same time, class, because of their property, which is they are dipole. They are polar. Okay? So sabi natin, class, si hydrogen can bind to the partially negative oxygen of the water molecule. So, pag nagdikit-dikit na yan sila, okay, hydrogen. So, pag nagdikit-dikit silang ganyan, so tendency class is, That's a dipole-dipole interaction, or a dipole-dipole force. Right? So, dapat iniba kong kulay. Mali. Okay, sige lang. Yeah. So that the force that binds them, dyan, this is called a dipole force or interaction or a Keesom force. Yun na lang. Are we good? Yeah. So class, again, that's an interaction between two dipole molecules. So again, this is the type of bond class that exists between water, hydrochloric acid. Kaya class, makikita nyo, these kinds of molecule exist in its what state? At room temperature. Are they solid? Si phenol, si acetone.
Liquid
Yes.
po.
Okay. These kinds of class of substances or molecules exist in liquid state. Okay? Kasi they don't have that strong bond. They don't have that much of a strong bond eh. Weak bond lang naman to eh. Pero at least magkakadikit sila. Medyo magkakadikit sila to each other. Okay? So how can I shorten the distance between one molecule for another molecule? What can I do? Paano ko sila pagdidikit? Si water molecule. Actually, if I apply heat, maghihiwalay sila. Okay? But if I reduce the heat, I freeze them, tendency is magdidikit sila. Okay? Creating a solid phase. So are we clear? So class, now you realize that the state of matter, okay, the state at which a matter exists is highly dependent on its temperature. At the same time, class, the type of force that exists between them. Kasi kung ionic yan, automatic, alam ko na agad, magiging solid yan. Going to exist in its solid state. Alright? Yeah. Or semi-solid. Yun na yun. So, pinakita lang naman dito, class, is yung, ito naman, hydrochloric acid, say, for example, this was HCl. Okay, how hydrochloric acid binds to each other to create a liquid. Okay? Kasi, class, kung single molecule lang yan, isang molecule lang yan, another molecule, it's going to exist in its gaseous states kasi hindi sila nagbabind to each other. Okay? Pero dahil kaya nila mag-bind to each other, okay, at room temperature, class, they bind to each other. So tendency is, ayan, dipole-dipole interaction, positive hydrogen binds to the negative chlorine. Right? So ito, hindi na makita. Okay, basta yun na yun. So they exist in their liquid states. Okay? So pinakita ko lang naman ang binding naman between water molecule and hydrochloric acid. Okay? So same lang naman, class, ang principle behind this. What I'm simply showing here, class, is I can add water to hydrochloric acid, definitely. And if I add water, class, to hydrochloric acid, I don't just simply dilute them. They interact with each other and create a dipole-dipole force. Are we clear? Okay. Then HCl. So one chlorine molecule, one hydrogen molecule. Si chlorine may pag-bind sa partially positive, okay? So I can't say na fully positive siya, pero partially positive hydrogen. Tapos si hydrogen naman magbabind sa partially negative oxygen. Now, let's talk about, class, the dipole-induced dipole. Yan, dito tayo pupunta ngayon kay Marupok, si induced dipole. Okay? Normally kasi, class, a molecule, especially a diatomic molecule, okay? Like oxygen, say, for example. Di ba, class, oxygen exists in its free state. Once it exists in its free state, lagi siyang O2. Ibig sabihin, diatomic siya. So, in its free state, oxygen will always be 2 molecules of oxygen. So, therefore, class, it's relatively nonpolar. Stable siya, right? Stable C oxygen. Okay? So, kumbaga, yung amounts of electron circulating between these two molecules is stable. Symmetric, kumbaga. Symmetric, pabilog. So, kumbaga, the amount of electrons circulating here is symmetric. Symmetric. Okay? Now, class, dumating si dipole molecule. Dipole such as water, say for example. Si water. Alam naman natin, class, na si water, partially negative, partially positive, right? Partially negative. Ang partially negative, si oxygen dito. Okay? Tapos ang partially positive dito, si hydrogen. Right? So ang tendency ngayon, class, is dahil electronegative or negative ang charge ni oxygen, symmetric to, pantay. Ang nangyayari, class, is yung electrons, dahil negative to, negative din si oxygen, yung excess amounts of electrons, class, ni oxygen between the two molecules, nare-repel papunta sa left. Dahil negative siya eh. Negative yung charge nito. Negative din to. So tendency is, napupush siya pag ganun. Napupush yung electrons papunta dito. Napupush papunta kay, pangalan natin ha, si oxygen 1, si oxygen 2. Okay. Once na nalapit si oxygen molecule kay water, most of the electrons ni oxygen 2 napupunta kay oxygen 1. Okay? Although, hindi siya class nagkakaroon ng very significant change, it's only a minor change in their charge. Pero significant enough to cause an attraction. Nagets ba? Nagets ba? Ulitin ko si oxygen marupok. Marupok siya. Okay, so ang tendency class is, pag na-expose siya kay oxygen, ever so slightly, nagkakaroon ng shift sa electron cloud. Kanina ang electron cloud natin is spherical, meaning equal ang distribution ng electrons between the two oxygen molecule. This time class, nagkakaroon ng parang ballooning. Nagkakaroon ng ballooning. Ballooning, ano? Wherein majority of the electrons, saan pumupunta? Pupunta sa left side. Okay? Napupunta sa left side kasi na-expose ngayon dito siya sa oxygen molecule ni water. Nagkakaroon ng repulsive force. So dahil lumipat sa left side yung most of the electrons, anong matitira kay oxygen 2? More on protons. Nagets ba? Nagets ba? More on protons. Okay, more on protons. So tendency class is yung spherical, yung symmetric shape ng ating oxygen molecule, naging induced dipole siya. Yung oxygen 1 naging slightly negative, si oxygen 2 naging slightly positive. Slightly. Take note of the term, slightly. Nagets ba? Kaya siya tinawag na induced dipole. The molecule, oxygen, became an induced dipole. Napilitan siyang mag-separate yung kanyang charge, okay, because na-expose siya sa isang molecule which forced oxygen to separate into two charges. Nagets? I can't say na fully separate kasi very, very minor lang class ang shift sa polarity niya. Very minor. Pero enough to create an interaction. Are we clear? Unlike class dipole. Sa dipole, alam ko agad may negative, may positive siya. Sa ion, alam kong negative at positive yan. Sa induced dipole, somewhere in between lang siya. Kasi very minor ang change sa charge niya. Kaya nga siya tinawag na induced dipole. Napilitan lang siyang maghiwalay. Technically, hindi siya separate positive, separate negative. Non-polar siya eh. Oxygen is a non-polar. Are we clear? Okay, pero dahil nga na-expose siya sa water molecule, so yun, medyo naghiwalay ngayon yung kanyang electrons. Na-push back yung electrons, napunta kay oxygen 1, kaya natira kay oxygen 2, puro protons na lang. So naging mas positive ngayon yung si oxygen 2. So ang tendency class is, nagkakaroon ngayon ng interaction between the oxygen of water and this oxygen molecule. Maliwanag? Kaya class, the interaction between oxygen and water is what we call a dipole-induced dipole force. Okay? Alam niyo naman siguro class, di ba, natutunaw ang oxygen sa water. Kaya nga nabubuhay ang isda sa tubig. Tama? Kaya nga pag walang oxygen ang tubig, ano nangyari sa mga isda? Kakaroon ng fish kill. Di ba? Namamatay yung mga isda sa tubig kasi naubos yung oxygen nila doon. Right? So class, pwede mag-interact ang oxygen with water molecule. Okay? And that interaction between them, class, is what we call a dipole-induced dipole, okay, interaction. Right? A dipole-induced dipole interaction. Para mahiwalay lang. Kasi mamaya, alam mo nung nung estudyante ako noon, kala ko, dipole-induced dipole. Sabi ko, ano yung induced na yun? Yung pala, dipole-induced dipole. Kasi hindi ko talaga mag-gets yung chem teacher ko. Okay, back when I was a student. Alright? Ngayon, nung tumanda-tanda na ako sa akin, ganun lang pala yun. Buisit. Hindi ko naintindihan. Pero anyway, napasa ko naman na yung chemistry ko nun. Okay na yun. Importante class makapasa. Magkaroon na kayo ng honors, that's a bonus. Okay? Actually, hindi makapasa. Importante talaga is matuto. Okay? Aanhin ko yung pumasa ako, hindi naman ako natuto. Okay? Kasi real life is harder than being a student. Alright. So sabi nga natin, dipole-induced dipole is also by forces. So it's an induction type of interaction. In-induce mo eh. I-induce mo yung isang molecule to separate into its charges. So the attractive interaction between a permanent dipole and one molecule with an induced dipole. Sino yung permanent dipole between the interaction here? Sino si permanent dipole? Between oxygen and water. Who's a permanent dipole?
Water po.
Definitely, class. Ang permanent dipole natin dito si water. Permanent na yan eh. Hindi naman nagbabago yan eh. Talagang maghihiwalay ang positive at saka negative charge niya. Ang induced dipole dito si oxygen. Kasi napilitan lang siyang mag-separate into its positive and negative charge. So, are we clear? Just so you know, class, yung mga quizzes natin, kailan naman mga tatanong ko. Bigyan kita akong picture, tatanong ko lang dyan, no? Which one of the two is induced dipole? Whatever interaction exists. Yan, ganyan. Okay? Okay, so it's named after Peter Debye. So, ito yung sinasabi ko kanina, class. If an oxygen molecule, class, O2. So, usually, non-polar siya. So, ibig sabihin, ang electron cloud niya, paikot-ikot, symmetric. Symmetric siya. Okay? So, ngayon, ang nangyari dito is, nagkakaroon ngayon ng shift. Okay? In terms of its charge. Ang pinakita niya dito, yung positive yung umumbok. Kanina pinakita ko yung negative yung umumbok eh. Alright? Pero, either way, basta dapat may label. Kaya napaka-importante ng label talaga. Okay? Kahit sa anong bagay, di ba? Sa pharmacy class, it's always important to have a label. Kaya nga, di ba sabi lang, pag mangliligaw ka ng pharmacist. At least alam mo may label kayo. Alright? Ay, hindi rin? Hindi rin ba? Okay. Anyway, so ito class, ang label dito is yung umumbok, yung nagballoon na side, dominant side is yung positive. Right? So, ibig sabihin, more protons here, more electrons ditong side na to. Okay, and this side, it's more on electrons. This side is more on protons. Alright? Yeah. So, dito, since it's already a dipole, it's a permanent dipole. So, obviously, class, the positive side will be attracted to the negative side of the permanent dipole. Okay? So, kumbaga, naghiwalay lang siya. Ganun. Right? So, a polar molecule can produce a temporary electric dipole. It's just temporary, so don't worry. Okay? In a non-polar molecule that are easily polarizable. So, energy of attraction is only 1 to 3 kcals per mole. So, ibig sabihin, class, tingnan nyo ha, ganyan lang kaliit yung energy that exists between it. Kaya yung dipole, 1 to 7. Okay? Ito 1 to 3 lang. 1 to 3 kilocals. So, ibig sabihin, mabilis lang ma-break yung bonds na to. Okay? So, kumbaga in a relationship, ito yung ligaw-ligaw lang. Si dipole kanina, magjowa na. Si ionic bond, kasal na yon. May kasama pang anak. Okay? May kasama pang mga anak. Alright? So, yun siya. So, it's easily polarizable molecules includes ethyl acetate, methylene chloride, and ether. So, it's a dipole-induced dipole. Now, what about induced dipole forces? Okay? Ito class yung force that exists between diatomic molecules. Pag sinabi natin diatomic atoms. Right? Such as nitrogen, iodine, bromine, oxygen, yung mga tinanong ko sa inyo kanina. Okay? So, what type of force exists between them? Okay? We say, class, that's the London forces, London dispersion forces, basta mga yun. Okay? So, London force or the induced dipole force. Okay? So, masyadong mahaba yung induced dipole. London forces na lang. Okay? So, class, some atoms are perfectly symmetrical. So, no dipole exists. So, electrons are in constant motion. So therefore, because molecules such as noble gases and halogens exist, the bond between them is usually a London force. Okay? It's a London force. So a London force class, sabi ko nga, symmetrical distribution of electrons. So there's an instantaneous dipole moment due to asymmetry. Okay? Pero technically, almost the same na yung shape niya. Balance, kumbaga, yung sharing of electrons na nangyayari dito. Okay? So na-induced dipole ko rin siya kasi more on negative, tapos yung positive side dito, nag-attract sila. So this moment, this dipole moment, this moment in time, naging dipole sila. Okay, we call this an induced dipole, or what we call the London forces. Okay, that keeps them together. Are we clear? Kumbaga, an induced dipole and an induced dipole bonding together. Right? So, originally kanina, hiwalay lang sila, symmetric. Tapos ang nangyari, nagkadikit lang sila. Halimbawa, si oxygen sa oxygen. So, nagkadikit sila, tendency, yung electrons sa potential side, yung protons dito. So, same thing happened to the other oxygen. Okay? So, yun. So, kumbaga, ito yung, kung si oxygen to, oxygen 1, si oxygen 2. So, yung kanyang protons, napunta dito. Dito si electrons. Same thing happened sa other oxygen. So, yung attraction between the electrons and the protons here, becomes what we call the London force. Sana bukas okay na to. Okay, the London force. Okay? Yeah, we call that a dipole moment. Kasi class, alam niyo ba kung bakit dipole moment lang to? Because it's just a moment. Kasi sooner or later class, magbe-break yan agad. Makakita lang yan ng another dipole, mabilis mag-break yan. Are we clear? Kaya it's just a moment. Kumbaga, fling lang to, fling lang. Okay, fling lang to between the two oxygen molecules. So, are we good? Okay, it's just a moment. Kumbaga, a moment of weakness. Whatever. Yun na yun. Okay? Yeah. Huwag natin pag-usapan. So, London force class also has dispersion, London dispersion forces. So, attractive interaction between any pair of molecules, including the nonpolar atoms. So, named after Fritz London, responsible for the condensation of nonpolar gas molecules so as to form liquids. Okay? Kaya nga, class, tingnan nyo I can liquefy nitrogen, correct? I can liquefy nitrogen. Kaya nga tayo may tatawag na liquid nitrogen. Diba, nitrogen class, the air I'm breathing right now contains nitrogen molecules. May N2 dyan. Yan, naamoy ko yung N2. I can discern ilang N2 naamoy ko. Lupit naman ng nostrils ko. Okay, pero class, technically, nitrogen is just in the air, right? Pero you can liquefy it, class. And if you liquefy nitrogen, class, you need to keep them bonded together, right? The nitrogen molecules should be bonded together. Okay, hindi lang nitrogen to nitrogen. Okay, ibabind ko sila. And usually, class, the force of interaction that I create between them is a London force. Kaya nga, class, open liquid nitrogen in room temp, ano nangyayari? Nagiging gas ulit siya ulit. Kaya kita nyo ng liquid nitrogen, class, umuusok. Okay, at room temperature lang yun, at room temperature. Kasi, class, very unstable yung forces holding the nitrogen together. Konting difference lang in temperature, they break na and become gaseous state ulit. Amazing, isn't it? So nagets ba, class? Kasi napaka-weak lang ng London forces. Kaya nga, dipole moment is just a moment of interaction. Okay, that I can always break anytime. I can easily break. Very good? Yon. Okay. So, originate from the molecular internal vibration in non-polar molecules to produce attraction that rise between the synchronous fluctuating dipoles of neighboring atoms, whatever. Okay, basta naintindihan nyo kung anong nangyayari between the dipole and induced dipole, we're good. Okay? So, responsible for the liquefaction of gases, and the energy of this attractive force is only 0.5 to 1 kilocalories per mole. Kaya nga, class, a bit of heat, a little heat lang, class, like, wala pang 1 kilocal of heat. Kasi kilocal per mole, it refers to energy, Okay, we're referring to energy here, kilocalories. Okay? So, just a bit of heat, class, will break the bonds existing between molecules, induced dipole forces. Okay, or a London force. Exhibited by organic compounds like carbon sulfide, carbon tetrachloride, kaya mabilis mag-volatilize. Alright? Kaya, class, if a drug, or if a molecule has a London forces lang, okay, they can easily volatilize. Kasi mabilis sila mag-volatilize. So, halimbawa, magbibigay ako sa inyo ng picture. Isang ionic compound, isang induced dipole. Tatanungin ko lang dyan, which of the following would be ideally used for inhalants? Would be ideally used as an inhalant, an ionic compound or a compound with London forces?
London forces.
Definitely, class, yung may London forces. Kasi at least at room temp, kaya ko siyang volatilize, ipa-exist in its gaseous state. Okay? So, mga ganon. Yeah. All right. Of course, class, pressure and temperature plays a vital role in how we can liquefy gases. Okay, next one is ion-induced dipole. Konti na lang. Oh my God, I'm overtime na pala. Matatapos ako. I'm so sorry. Matatapos na ako. Okay, a non-polar molecule may be polarized by presence of an ion near it, that is, and it becomes an induced dipole. So basically, class, ganito lang naman yan. May ion, such as, say, for example, iron. Meron tayong induced dipole, like oxygen. So what do I get if I combine both? I get ferrous oxide. Okay, ferrous oxide, which is rust, right? Okay, it becomes rust. So that the interaction, class, between iron and an oxygen molecule, oftentimes, class, that is an ion-induced dipole. Okay, another interaction, class, would be between iodine and potassium. Okay, iodine, class, is another induced dipole. It's a halogen. So obviously, since it's a halogen or noble gases, automatic induced dipole ang interaction nilang dalawa eh. Okay, so involve the formation of iodide complex solubility, which allows the solubility of iodine in a solution of potassium iodide. Okay? And then lastly, kasi hydrogen bond, this one is important. It's actually just dipole-dipole, much stronger lang. Okay? And ang keyword kasi dito class is hydrogen bond. So saan nangyayari yung binding? Saang molecule?
Hydrogen.
Okay, very good. Ang nakikipag-bind lagi si hydrogen. Yeah, hydrogen bonds ang tawag dito. It's a special kind of dipole-dipole force. Okay, wherein it's much stronger than your ordinary dipole-dipole. Okay, it's much stronger than the ordinary dipole-dipole. Pero not stronger than covalent, definitely, or ionic. Kasi it's hydrogen bond is technically still under van der Waals forces. Pero hiniwalay lang natin siya kasi we want to give it more emphasis. Okay? So when a hydrogen atom is bound to an electronegative atom, such as oxygen. And this is the most common type of bond class that exists with our drugs. Okay, hydrogen bonds. Okay, so if I want to break a hydrogen bond, anong gagawin ko? I usually just do hydrolytic reactions. Okay, I'll let it undergo hydrolysis. All right, so with the use pag hydrolysis, ang reaction na yun requires the use of water. Okay, so interaction between a molecule containing a hydrogen atom and a strongly electronegative atom such as fluorine, oxygen, or nitrogen. It accounts for the high dielectric constants of water. The hydrogen bonds class allows for the high dielectric constant of water, meaning talaga makikita mo na may positive charge ang water, may negative side din siya. Okay? Now, low vapor pressure and high boiling point of water. Okay? Now, it exists between alcohol molecules, carboxylic acids, aldehydes, esters, and polypeptides. So these are some of the molecules class that have hydrogen bonds. So kumbaga, between aldehydes, kung this is an aldehyde, aldehyde na lang, al na lang and an aldehyde, the bond that exists between the two class would be a hydrogen bond. Same goes with esters, polypeptides. Polypeptides class are the bonds that exist between peptide bonds, like amino acids. Okay? So what binds them together would be a hydrogen bond. Right? Or carboxylic acid. Or, syempre, pinakamadali na lang dito is water. Okay, water to water, ang nagbabind sa kanila would be, alcohol. Alright, so alcohol, what binds them together would be a hydrogen bond. Okay? So, are we good? Very good. Okay. Diba kasabi natin kayo na basta covalent bond may sharing. Okay? May sharing of electrons. Kasi baka tanungin nyo ako, sir, akala ko ba kayo na pag water to water, baka covalent din yun kasi may sharing. Kasi ang hydrogen molecule nakikipag-share kay oxygen. So baka sabihin nyo, ano yun, sharing. So covalent. So actually class, the covalent bond here exists between the oxygen hydrogen within the molecule itself. Kaya nga sinabi natin kanina is, it's an intramolecular force of attraction. Intramolecular force. Now class, the sharing naman kasi between a hydrogen, very specific to the sharing between a hydrogen and the oxygen from two water molecules is the hydrogen bond. Are we clear? Kasi intermolecular attraction to. Pero pag intramolecular, within the molecule itself, the sharing between hydrogen and oxygen is a covalent bond. Okay? It's a covalent force. So are we clear? Kasi baka balikan nyo ako, sabihin nyo, sir, di ba covalent is sharing? Yun na nga. Okay, so explanation ng class is, covalent is intramolecular usually. Okay, within the intramolecular, within the molecule itself. Okay? Tapos pag hydrogen bond, that's the sharing of molecules between hydrogen and another electronegative compound. Okay? Molecule to molecule. Right? Okay, so ito class, parang ano lang to, mnemonics. How will I know if what type of bond exists? Okay, so halimbawa, interacting molecules or ions. Are ions involved? Yes or no? Kung yes, ang next question dyan, are polar molecules and ions both present? Kung yes, most likely, baka ion dipole force yun. Alright? Kung wala naman, okay, pwedeng, walang polar molecule. Right? So meaning purely ions lang. So therefore, could be an ionic bond. Right? So kung wala namang involvement ng ions, hindi involved ang ions natin dito, so are polar molecules involved? Kung no, then obviously, London forces yon. Kasi di ba si iodine, non-polar sila eh. So walang involvement ng polar molecules. So no, London forces most likely yon. Okay, kung may involvement ng polar molecules, are hydrogen atoms bonded. Okay, are hydrogen atoms bonded to electronegative atoms like nitrogen, oxygen, or fluorine, or fluorine. Okay, so if yes, then most likely that's a hydrogen bond. If no, then most likely dipole-dipole forces lang yan.